Hello, everyone. Thank you. I would like to thank the organization for inviting me to this Digital Data Science Summit in Cabo Verde. My name is Clara Higuera. I work as expert data scientist in BBVA. BBVA is the second largest bank in Spain. And today I would like to tell you about my NLP adventures in this financial organization. And I will do it walking you through a real use case. So usually when we talk about data science, we focus a lot in the phase of training the model. What algorithm are we gonna use, or are we using? How are we going to tweak the parameters, etc. But if we want our models to have an impact in an organization, we need to take care of other stages that are equally important if we want our model to reach our users. So I'm going to talk about all these stages from business need or problem definition to the productionization of the model. So to give you a little bit of context, I work where I work in BBVA. Most of our clients communicate with their financial advisors through the app, and especially now in these times of pandemics. Financial advisors communicate with the clients with through text, through messages, through the app. So in my team, what we do is we build AI products that assist financial managers to do their work. One of our goals is to help them decrease the average response time per interactions with clients, but it reaches other goals as well, like how can we help them answer the clients as well. So just to give you some examples of the projects we are working. For example, we work on classifying conversations, or what are the clients asking us, or what do they want, or how can we assist them. We are working also in doing some research on automatic response, but more than automatic response, we are doing some research in finding out whether we can build a system that suggests the financial advisors some answers, because sometimes the answer is quite general and not specific to a user. So, for example, that would be a case that would make easier responding to that client. And also we are working in routing. For example, some financial advisors have experience in mortgages, loans, and these kind of financial products, while others have expertise in others. So depending on the question of the client, the message can be directed to a certain type of agents. And in all of these projects, there are some commonalities. So there is a business need or something that we want to solve, and then and at the other end of the maze, we have that model that lives in the infrastructure of the bank, and in the middle we have all that maze. That's why I make the analogy with video games, because no matter how much you know about these type of projects or data science projects in production, there will always be some obstacles that you need to overcome. Sometimes you will know about those obstacles, but other times you will have to be creative. So after years of experience in different sectors, I have come to the conclusion that one have to be very creative, and it's a bit like a video game sometimes. So who's playing? Today I'm going to tell you about a use case that we have we have worked in my team. And in my team, we are data scientists, data engineers, business leaders. We have also product managers, and we all work together in different projects. It's a very multidisciplinary team, and I will talk a little bit about that later, and how it is important that the team is very aligned and that the communication works well. So what is the real case that I'm going to talk to you today? So I'm going to talk about a conversations classifier that we have already put into production in the organization. And here I have split it, the stages that we've gone through in five ones. So first, I'm going to talk about the problem definition. What were we trying to achieve? Then we need to see whether the data that we have are available and what type of data do we have to start that project. After we know that we have the data, what are we going to do with that data, and how are we going to ingest it? Do we have to build a pipeline that ingests data every month, and how are we going to do that? So the model is, or so we prepare the data for training that model that we want to deploy. So then it comes the famous phase of model training and validation, and at the end we will have the process of putting that model into production, so it becomes live and then it can interact with our users. So we're going to start with the first stage. And so financial advisors, once they interact with the client, they need to, well, after having solved the request or the question, they need to tag the conversation with two labels. One is the product and the other one is the operation. So, for example, if the client comes and writes saying that he wants to cancel the credit card, the product would be a credit card and the operation would be cancellation. The same will the same process would be if the client is asking something about his or her mortgage, and then the product would be mortgage, and then the operation that the client wants to or is requesting. So this is a task that is time consuming, and that the financial advisors need to scroll down and look for the proper label, etc. So it's a bit sometimes maybe even annoying. So what we want to do is we want to build a model that suggests those two labels, so the advisor doesn't have to invest time in that task. Okay, so the second stage is what data do we have available? So these are graphs of the volume of conversations that we have about the different financial products. We have around 32 products approximately, and 120 operations. So when we started working on this project, we had a history of data of 200,000 conversations that were labeled by the call center, so financial advisors that were working as a call center. And this will be important in later stages. So, okay, we have the data, we have the messages, we have some labeled data by historical labeled data. So what do we do with that? Here it comes the data ingestion and pre-processing stage. So here, this is common to many data science projects, but especially in natural language processing, we all, because we are dealing with text and we want to use these techniques, or these are the techniques that are going to make us possible to extract value from the text, we will need to do some pre-processing or processing of that data. So on one hand, we will have the pure data, so to say, for example, messages, conversations, assistant manager information, those labels, the products and operations. These are the data that needs to be transformed in a proper way to so we can use it later. But also we need to do some processing. We need to identify the language, because sometimes we get messages in English or in a Basque or Catalan language. So we need to do that language identification. We need to also do some anonymization. So all the ID numbers need to be removed, also credit card numbers, etc. And also we do some name entity recognition as well. So all these processes are going to take place in this pipeline that we build. So with the final goal of building or having at the end of this phase a data set that is ready to use for the training phase. So something important is that this needs to be designed so we can, for example, every month get new data. So it has to be robust, and it's quite time consuming as well. One of the stages that takes most of the time. And then it comes the model training and validation. So usually, if you're familiar with data science and machine learning, you will have identified the type of problem we're dealing with here. So we have a classification problem, and the way one way of solving it is by using supervised classification and specifically classifiers. So, but when we use this type of classifiers, we usually have elements or data samples, and those samples are described with real numbers. For example, if we want to classify plants, we will need information about its attributes. So how big the leaves are, or how what is the color, or what is the shape of the leaves, for example. And then, so once we have the information in numbers, then we can put that information or give that information to a classification model, and with those values, it will be able to discriminate between those classes and tell us for future examples what type of plant is that. So what happens with text? Here we're dealing with text, and we have conversations of our clients. So we need to translate this text into a numerical representation. And there are two ways to do this. One that is quite traditional already is using the strategy of bag of words. So we have sentences or texts or paragraphs, and we would like to transform that into a vector of numbers. So we take each word in the sentence, and we calculate the frequency of that word in the sentence, or in the paragraph, or in the conversation in our example. So, for example, in the sentence, John likes to watch movies, Mary likes movies too. So John appears once. So then we will have that vector of words with the frequency. So likes appears 3 times, two appears 2 times, etc. So these numbers are going to describe our sentences. There is another second approach that is based on this one, bag of words, which is TF-IDF. And what it does is it penalizes the words that are that appear many times in every phase. So those words won't be discriminant. So this index penalizes them a little bit. And the second approach is word embeddings. So word embeddings are models that map words or phrases into vectors of real numbers, but with the difference that words that share the same context, they will be transformed into a vector of real numbers that will be mathematically closer than to other words. And this is important because with the bag of words approach, we don't keep track of the context. So now, especially in deep learning approaches, word embeddings are very popular and outperform other approaches. So once we have converted our text into a vector or a numerical representation, we have many types of classifiers that we can choose, like random forest, naive Bayes, support vector machine, logistic regression, neural networks, etc. So how do we go about choosing one of them? Which is the best one that adapts, or it's the most adequate for our problem? So here comes the stage of validating the problem. And validating the problem, well, there is the first thing that we all need to do, which is splitting the data set into training and test. So we use part of the data, most part of the data to train the model. And once the model is trained, we will test it with the test set, which is a sample, well, a set of samples that the model hasn't seen in the training. So this will give us information about how well the model generalizes for future cases that will come and that have been unknown to the model. So in this graph or table on the left, you can see some numbers. These are the precision and recall for each of the categories that we're going to, or that we are predicting for the for the test set. But here comes some questions. So, for example, if we want to, if we deploy this model, how do we know how it's going to perform in the future, in the coming months? So, for this, we created a way of validating our model, which is we call temporal validation. So this is very easy to do. The validation is similar to the one I just said, but so for we take as training data set some months, like for example from January to April, and then we test it with May. The second experiment can be training from with data from January to May, and then validate it with June. And then the third experiment would be to train with data from January to June and then test it with July. So what we found with these three experiments is that the variance between the metrics that we got from the different months was very little. So there was very little variation, even though we had different volumes of conversations from the different categories. So there was little difference between months, which means that the model is quite stable. The third type of validation that we came up with was a manual validation. And this is very common in natural language processing practice. And in our case, this was very useful because, as I explained earlier, our model, our data was labeled by the contact center. So in VBVA, we have two different roles. So the advisors that work in the contact center, they are focused on products like accounts, cards, invoices, bills, transfers, etc. But there are others that are experienced, and they manage other type of products like mortgages, investment funds, insurance policies, etc. So what happened was that the data that we had labels was mainly from the contact center. So and the products of those other advisors, we didn't have many of them. So the thing is that this model was going to be deployed for this role of advisors. So we weren't sure how was it going to perform. Also, in addition to this, there are when people label data, they are actually doing something. Well, they have to focus on their work. So sometimes there are some human bias, and sometimes managers do not label as thoroughly as it's needed for the models to avoid noise. So we decided to, among the members of my team, to manually annotate some conversations of these products. So I could talk long about this process, but I'm going to give you a summary, and I think it will be enough for this purpose. So what we did was we took a data set of 1,200 conversations that were not labeled. So we didn't have labels for those conversations, and then we did the first test. We took 120 conversations, and we were 12 of us who were going to label those conversations. So after annotating manually and saying, okay, this conversation is about investment funds, this conversation is about this other product. So we are not financial advisors, so we weren't sure how well we were doing it. So in order to find out how aligned we were, or how much we agreed on the annotation, we used an index called Kappa index, which measures the agreement between pairs of annotators. So here I have pasted the values that this index can provide, and a ranking of values. So it could be said that from 0.6, it's a moderate agreement. So it's the threshold from which we can start talking about some like proper agreement to give as valid our data set. So after the first round, we got an average of 0.45, which was quite bad. So what was happening? There were inconsistencies in how we understood the product, the financial products, or also there were some, like, we were interpreting the guidelines for annotation differently. So we did 3 more rounds of this annotation process until after 3 rounds, we finally labeled 1,200 conversations between the 12 of us in groups of 2. So each conversation was labeled by 2 people at least to keep measuring the alignment. So at the end of the 3rd round, we saw that we reached an average score of 0.55, but in most of the conversations or the products, we got an index of over 0.6. So at this point, we were sure that we could use that data set as a validation or another layer of validation for our model. After having tested the different types of models with these data sets, we came up with the results. Well, the results that we obtained were that the super vector machine was the model that was more adequate, or that gave us more precision and recall in both of the data sets. So we took that as the winner, so to say. Yes, so we have gone through all these 4 phases, and now we need to put that model into production. So how is this going to work? So this model, it's already trained. We're very happy. And where is it going to live in the infrastructure of the organization? So first, once this is the financial manager's interface. So once the manager receives a question from a client, and then it can push a button that says classify. This button will call to our model, which with the text that of the client will process it, and it will output a prediction. Then the prediction will give the product and the operation, and the manager can say, well, yes, I agree, these are the labels, and then I accept it, or either I don't agree, so I will choose my own categories. This looks very simple in this scheme, but it is a bit more like this, and it is already a simplified picture. So this button that is asking for classification, it's going to call to an API. This API is going to go to our model, or actually it needs some preprocessing, like converting that text into mathematical representation, then some preprocessing for for the model, and then the model will give an output. Here we have the business logic, which is, okay, for example, we don't want the model to suggest anything unless it has a 90% confidence. See, this is what we call business logic. So it's something that we need to implement on top of the model, and then it will go to the prediction. So these characters that you can see here are different teams in the organization. So there are the people that are working on the interface of the tool of the financial manager. This is us. Then there are people that are that work on all the infrastructure, web infrastructure of the bank. And then also there are some people that are running tests and to make sure that we don't receive too many calls to the model, and that they make sure that we don't break anything inside the bank. So I'm saying this because I already mentioned that in my team we are a multidisciplinary team. So it is very important to be able to communicate what your needs are and what you need from others, and to make sure that all of us are working for the success of this project. And sometimes this is complicated, so it is a real success when this actually works, and this model is actually now in production, and the financial agents are already using it, but it takes a lot of effort. And I would like to, because I know that there are business leaders listening, I think also that it is the role of a leader to facilitate that conversation, and it is extremely important for the success of these projects. And well, I would like to finish with the last takeaway from my talk. And I would finalize with saying that no matter in which stage you are in the process of this data science project or NLP project, that you will always most probably have to go back to previous stages. So, for example, once your model is already in production and your users are using them, maybe you want to improve your model because you have new data. Actually, you also have the feedback from the users that is saying, no, this label is wrong. So you can go back to model training and validation and improve your model and deploy it again. And sometimes you find that there are other variables that you could be using or some information. So you can go, you need to go back to the pipeline building and ingest that new variable so you can use it for your data. And sometimes even you need to go back to the problem definition. For example, 2 weeks ago, we found out that in the categories that we were classifying, we had different types of categories. We had financial products, but we also had, like, for something called documentation or complaints. So those are not financial products. So maybe we need two classifiers and we need to rethink on that. So it is a process that is very iterative. And this is also what reminded me of a video game, that you go back and forth until you reach your goal. And that would be it. I think we have maybe 1 or 2 minutes for questions. I hope you liked it.